What you place in the cell.
So given that two masses are there, M1
6 kg.
6 kg, M2 40 kg. So M1 is now with initial velocity of
2.3.
2.5 meter per second. It is colliding another body which is at rest. So after collision, it is moving with the velocity of 1 meter per second in its original direction. Then what should be the final velocity of second one is the question. So we know that it is an elastic collision. It is an elastic collision, right? It collides head on elastically the stationary mass. So for elastic collision, for elastic collision, I can say V2 is equal to M1 by M1 plus M2 into U1 plus M2 minus M1 by total mass into U2. Because U2 is 0, this term becomes 0. So it is equal to 2 into M2 is M1 is what?
6 kg.
M1 is 6 by total mass is 10 into U1 is 2.5. 2.5 for 4 times. 2.5 4 times. 2 2 times. 2 3 times. 3 times.
Answer is
So if it is elastic collision,
the formula is M1 plus M1 plus M2.
okay, so it is mentioned. So it is mentioned that it is head-on collision, but it is not mentioned as it is elastic or inelastic. So if it is elastic, then only this formula is applicable. Okay. So for elastic collision only. So if it is elastic collision, V2 is equal to 3 meter per second, right? Now, usually just if you have thought it is elastic collision, but that is a kind of common mistake. So we can say that as it is not mentioned that the collision is elastic because it is not, so this is not correct. So it is not mentioned that the collision is elastic, but for any collision momentum will be conserved as moment p is conserved for any collision we can say from law of conservation of momentum. Initial momentum is equal to final momentum. So initial momentum is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Right? Here u2 is 0, it becomes 0. M1 is 4. 6 into u1 is 2.5 is equal to m1 is 6 into v1 is 1. So plus m2 is 4 into v2. V2 is supposed to find. So it is you can write this as 4v2 is equal to 6 into 2.5 minus 6. So 6 is common, you can take this out, then you can write 2.5 minus 1 is equal to 2.5 minus 1 is 1.5. So 6 into 1.5 can be expressed as 3 by 2. So 2 threes. So it is equal to 9. Correct? So V2 is equal to 9 by 4 or 4 2's 8. 1 is there. So it becomes 4 again at 2's 10. Again 2 will be there. So 4 5 8. So 2.25 meter per you can say it. Correct? So usually we'll think that this is the expression, it is expression only for elastic collision, but it is not mentioned that the collision is elastic. So I have to do
Right. Yes, yes. Correct. Yes. Physics only? Hmm? How many have completed? Till now. That also is fluctuating. Hands are like fingers are flickering. Finish fast. This becomes this quick.
I haven't what you call sweater I'm getting at what this I have done.
this one. So which one? Which one you have discussed?
What you thought me was that time with the I am getting answer. Not before this
So the question is, what is this question?
Diksha, finished? How many? So I have to show given questions tomorrow. So night we will do. Very. Time up. See. So today no dinner for our girls. They are more energetic. They came from home today only, right? No need of dinner, right? They want to do homework. Yes? After completing homework, we'll go. Yes? They only want to go. So, but tomorrow without fail, you guys have to show. Right? Right. Okay then, go ahead.
Question number? Neutron.
Don't forget on everyone. Boys, I have time. Try to finish. Girls, this week, at any cost, you have to score physics. How much? Don't know. How much, Pavitra? How much you will score? One? Very good. Yes. Okay.
So neutron travel fast B and energy relax perfectly elastically. Perfectly elastically done with nucleus. Perfectly elastically. Done with nucleus of an atom of mass A and S. At Newton megawatts. V1 M minus M2 M minus M2 elastical unit they are given. So M1 is M, M2 is atomic mass into M. So okay, 1 minus here A by 1 plus A into U1, right? Yes, U1 is not mentioned here. This V directly you will get this thing. Oh, so we are getting 1 minus A by 1 plus A.
Yes, sir.
So you can write this a minus 1 by plus 1 also. Okay. Negative sign. Here in the denominator, negative sign is there. It is not there.
This plus you can see.
But because it is a square, of course you can 1 plus a by 1 plus a whole square. Take minus out. A minus 1 by a plus 1 also you can take it. Because it is a square, even if you take the minus out also, nothing will happen. So if these two options are there, then you have to be careful. But here in this, even if you take minus, that is not affecting this with the other ones, right? So you can take it. You can cancel this one. Because it is also elastic. Again, formula can use it for elastic version. You can use it.
Yes, guys. Hmm?
Question number 42.
Hmm.
Washroom, huh?
Come fast. Don't go to dining hall directly.
Question number 42, right? What is going here? From the top of a tower of height 100 meters, a 10-gram block is dropped free and 6-gram bullet is fired vertically up from the foot of the tower with velocity 100 meters per second simultaneously. They collide and stick together. The common velocity after the collision is. Here we have to use the relative velocity concept. Yes. Question number 42. This is a very nice question. Very important also. Question number 42. Page number 8. Listen. The question is, from the top of a tower of height 100 meter, a 10-gram block is dropped freely and a 6-gram bullet is fired vertically upwards from the foot of the tower and with a velocity of 100 meter per second simultaneously. They collide and stick together, then the common velocity after collision is given g, small g is equal to 10 meter per second square. Options are given as 27.5, 150, 40, 100 meter per seconds. So, how to proceed? Let us try to understand this. It is mentioned that there is a tower. There is a tower whose height is which is equal to 100 meter tower. From the top of the tower of 100 meter, a 10-gram block is dropped. Let us say this is our M1, 10-gram block. Let us say M1. M1 is equal to 10 gram block is dropped. Means its initial velocity U1 is 0. And at the same time, simultaneously, small bullet, let us consider this is M2, whose mass is 6 gram. A 6 gram, a 6 gram bullet, 6 gram bullet is 6 gram bullet is fired upwards. So here initial velocity of this is of course u1 is 0. Initial velocity of the bullet is u2 is equal to 100 meters per second.
Hey guys, what are you doing, man? Finish fast, finish the work. Go and sit. Hey, what you are doing, Ra? Dinesh?
So a 6 gram bullet is fired up with the initial velocity of 100 meters per second. 100 meters per second simultaneously, means the moment it is dropped here, really that same time it is projected upwards. So if you observe the block from the bullet, velocity of the block with respect to bullet, when you observe here, even though it is released from rest, it is with what speed it is observed, it is moving. The same speed appears to be coming downwards because the relative velocity of this when they are moving in opposite direction is equal to sum of the velocities. So u1 plus u2. Initially it was having 0 plus this, so it appears to be moving the same velocity down. So it is equal to 100 meter per second velocity of block with respect to bullet. And it appears to be because both are moving under gravity, the acceleration due to acceleration of block with respect to bullet or bullet with respect to block will be 0. Both are same. So and here gravity on this is downwards, on this also downwards, and same actually in same direction. So g minus g will be 0. So it will be 0. But the distance traveled when both are traveling here, you can see the relative distance traveled. So by the time somewhere here, let us say after some time they meet. So somewhere here or whatever it is. So if the total distance is h, this has traveled some distance x, this has traveled h minus x, and total distance traveled will be h. So you can say traveled, the distance traveled x, distance traveled x will be distance traveled by bullet block with respect to bullet or whatever it is equal to, relative distance is equal to how much? 100 meters. 100 meters. And then what is the time taken for traveling that distance with this distance with this velocity? If you want, then you can say time is equal to what? Distance by speed. Distance is x by speed. So it is equal to 100 by 100 is equal to 1 second. That means after 1 second they will meet. Okay. So now what you are asked to find, if this is the case, what you are asked to find, if they collide and stick together, after some time, if both will collide and stick together and they're moving with common velocity, what is the common velocity? What is the common velocity? Is the question. When they'll stick together, they may move upward or downward, we don't know. That you can understand. Whatever it is. What they will move with common velocity. Initial velocity is this, and the final velocity will be common velocity. What is that? So to find it, we have to say, yeah, just before initially even that is dropped from rest from the tower, before hitting here, after traveling some distance, if you say this is some distance x, then this will be h minus x, right? So before hitting this, it has traveled some distance x, so it has obtained some velocity. What is that velocity obtained? Because of this, velocity is equal to root 2 gh. Root 2 gh. If you find what is this x, then you can find out that. So how can you find this? You can say yes, what will be the velocity here, final velocity after this time. So you can say that that final velocity will be acting as the initial velocity before collision. So this u1 u2 you should consider in this case. u1 will be here our v for the first one, right? It is equal to, or you can take it as this is equal to in terms of time, because by using the equation v equal to u plus at here, u for this motion u is 0, and u plus at a is minus g, so you get minus gt, minus g into t. So here minus of course that v also will be downwards, so you can take minus of minus cancel, then you'll get our u1 is equal to minus minus got cancelled, that g is 10 into this is 1, so it is equal to 10 meter per seconds, right? This is a u1 before collision. So this u1 is different, this u1 is different. Next, u2 for the second one. What is the initial velocity before collision? So before collision u1 is talking about before collision. u1 is the velocity obtained here, v1. So similarly u2 is velocity obtained after traveling some distance. What is that? Again it is equal to, because of the equation, so you can say v is equal to u plus at equation we are using. Here the essential velocity was 0, but it is projected with 100 meters per second. 100 minus g into t, so 100 minus g is 10 into 1, so 100 minus 10 is 90. So this u2 is 90 meter per second, u1 is 10 meter per second. But they are moving in opposite directions before collision. So what you have to tell here is to find the common velocity, as obviously it is moving with larger velocity before collision, its momentum will be more. So change in momentum gives force, force will be more in upward direction, this force will be more, so it will be moving upward, so after collision both will move upward only. So you can say that it is given as elastic collision, elastic common stick together and moving, right? So inelastic collision. So you can say for inelastic collision, what is the common velocity? Yeah? Common velocity is equal to, what is this? Is equal to m1 plus m2 divided by total mass. By using law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 plus m2 into v, right? So v is equal to m1 is 10 grams, 10 grams, grams means 10 to the power minus 3 kgs, u1 is 10, and if m1 is moving downwards, we have to take it as negative, right? That's negative. And this is m2 is moving up, we have to take positive. Plus m2 is 6 gram, 6 into 10 power minus 3 into its velocity is 90 by total mass. Total mass is 6 gram plus 10 gram, 16 gram. So 16 into 10 to the power minus 3. Minus 3 gets cancelled here. You take this out common, so it cancel. Then we have to get minus 10 into 10, minus 100. Minus 100, this is 9 into 6 how much? Plus 54, 540 divided by 16. So 540 minus 100, 440 by 16. Simplify this, you get this. What is this? 4 ones, 0, 4 fours. What they have given, they given fractions or decimals? Decimals. So 4 twos, 8, 8, then 3, 30. So 4, 7 is 28.55, 27.5 meter per second. This is how you are.
Third,
Yes, I don't know just the answer for your question. No? Yeah, the question is: a steel ball of radius 2 centimeter is initially at rest. It is struck head-on by another steel ball of radius 4 centimeter traveling with a velocity of 81 centimeter per second. If the collision is elastic, their respective final velocities are. As the here, so how to approach? What is given and how to approach? You have to carefully understand what is given first. A steel ball of radius 2 centimeter is initially at rest. Means it is the first one. First one is initially at rest. So let us mark here. This is M1 having of course radius R1, which is initially at rest U1 equal to 0, and it is struck head on by another steel ball of radius 4 centimeter traveling with velocity of 81 centimeter per second. So it is struck by another one, second one. Usually we will consider first one, then second one, right? So second one, to struck this, you have to travel in this direction. So let us consider second one to the right side. So this is M2 and having radius R2. Okay, the values are given. You can take the values of radii. R1 is equal to 2 centimeters and R2 is equal to 4 centimeters. R1 is 2 and R2 is 4 centimeters. And so that initial velocity of the first one is 0 and that our second one is 81 centimeter per second. So this collides this and this will be struck by this head on, okay, and if the collision is elastic, the respective final velocities are after this strike with this. So after collision, this will start moving with velocity v1. This also will be moving with a different velocity v2. So what are those velocities? v1 v2 is the question. So v1 v2s for elastic collision for elastic collision are given by this. Here u1 is 0, so initial velocity terms will become 0, only final velocity terms will come. That is one point you have to keep in mind. That is one point you have to keep in mind. And another thing, instead of masses they have given radii, then how to express that? For understanding this, you should remember, you should understand that we know that because density equal to mass by volume. From this, you can write mass is equal to density into volume on cross multiplying. Mass equal to density into volume. So here volume can be expressed as in terms of radius as the volume of a spherical ball it is, right? So steel ball is a spherical ball. 4 by 3 into pi r cube. Density into 4 by 3 pi r cube. Density for a given material constant. 4 by 3 into pi is a number. This is also constant. So you can say mass is directly proportional to r cube. Mass is directly proportional to r cube. So mass of the first ball is said to be proportional to r1 cube. Mass of second ball is proportional to r2 cube. M1 is proportional to r1 cube. M2 is proportional to r2 cube. Where r1 and r2 values are given like this. Then by making use of this, how to find v1 v2 is, let us see. v1 is equal to, as u1 terms are 0, v1 will be equal to 2m2 by m1 plus m2 into u2. Here m2 is proportional to r2 cube, so you can write it as 2 r2 cube by m1 is r1 cube plus m2 is r2 cube into u2. And okay, substitution we'll see later. And v2 is u2 term is u1 term is 0, u2 term is v2 is equal to m2 minus m1 by m1 plus m2 into u2. m2 can be expressed as r2 cube minus m1 can be expressed as r1 cube by m1 plus m2, r1 cube plus r2 cube into u2. Now let us substitute the values here, as v1 is equal to 2 r2 cube by this into use. So r1 r2 values are given. So 2 into r2 is 4. So 4 cube by r1 is 2 cube plus r2 is 4 cube into u2 is 81. And simplifying this here, you will get this one here. You get this as 2 into 4 cube is 64 by 2 cube 8 plus 4 cube again 64 into 81. So this further you can write it as 2 into 64 by 8 plus 64 is 72 into 81. Simply you can also cancel this as 9 yeah, with 9 nines, and can also directly cancel this as 9 8s 72, right? So and then you can simplify further. 8 64, so into 2, 8 into 62 is 16 into 9, it will give you 144. Okay, it's for understanding purpose I have cancelled first. 2 with 2 have cancelled 2 3s 2 2s, then okay, with 4, then you have cancelled finally, and you have got this one. That's just I have cancelled with the small numbers. Otherwise directly can cancel with the 9s and you can get it. So 16 into 9 is equal to 144 centimeters. That is v1. v1 is 144 centimeter per second. Then v2, as v2 is
this 0 plus this here already I have written in terms of r's. So r2 cube minus r1 cube by r1 cube plus r2 cube into u2. R2 is 4, so 4 cube minus r1 cube is 2 cube by r1 cube plus r2 cube is 2 cube plus 4 cube into 81. If you simplify this, 4 cube is 64 minus 2 cube is 8 by 2 cube 8 plus 4 cube 64. So 64 minus 8 by 64 plus 8 into 81 into 81, this entire thing into 81. This again will get it as 56 by, this is 72 into 9 81, so 9 8s 9 9s, again 8 7s 56, and simplifying this 7 into 9 will give you 63 velocity centimeter per second. So because the units are given in as CGS units, centimeters per second only, 81 centimeter per second, so we get 63 centimeter per second. So that is how we will get the values of v1 v2 guys. Okay, so when radii of the colliding particles are given, then final velocities can be obtained by using these expressions. Okay, so you have to remember this, how to replace mass in terms of radius, this you have to remember, then it will be simple. Okay, I hope it is clear. If you have any confusion further, you can ping me at any time guys. Okay, take care everyone, bye bye.